In this video, we're going to talk about angles formed inside circles, what I call internal angles. And we have three types of angles that we're going to look at. The first is what are called central angles. These angles are angles that are formed where the vertex of the angle is the center of the circle, hence their name. This angle here, angle AOB, is a central angle, and if you notice, the two sides that make up angle AOB, AO and BO, are radii of the circle. Now, the nice thing about central angles is that the measure of the angles, so the measure of angle, in this case AOB, is equal to the measure of the arc that it cuts off, in this case AB. Our next type of internal angle in a circle is what's called an inscribed angle. And just like we've talked about before, inscribed means written in. So this is an angle where the vertex is on the circle. So in this circle here, if this is A, B, C, the vertex is on the circle. Now, there are three very specific types of inscribed angles, although they all will follow the same rules. Here we have the three cases. The first one where the center of the circle is on one side of the angle, the second case where the center is inside the angle, and the third case where the center is outside the angle. Now, just like central angles, inscribed angles have a pretty simple way of finding them. The measure of angle ABC, in this case angle ABC is our inscribed angle, is equal to 1/2 of the measure of the arc that it intercepts. So 1/2 the measure of arc AC in this case. Now, there's one special type of inscribed angle that doesn't really look like an inscribed angle. That's when the angle is formed by a tangent and a chord. Now, this might look slightly different, but in this case, the measure of angle, and we'll need to give it another letter so we can name it something, D. So the measure of angle ACD is going to equal 1/2 the measure of arc ABC. Now, usually we do name minor arcs with only two letters, but just to clarify that that is the arc that we're looking at. Now, if we had another point on the other side, maybe we wanted to look at angle ACE, we would have to have another point. So the measure of angle ACE is going to equal 1/2 the measure of arc AFC. And the one thing that we already know from this is that if we have a chord, specifically the diameter or a radius, which is a portion of a chord, and where it intersects the tangent line, they're going to be perpendicular. We learned about this earlier in the year. Here we have our third type of internal angles, angles formed by two chords. Now, these can go through the center of the circle, but typically they don't. Because if they did, we could just use these central angles, which was our first type of angles. So here we have two different pairs of angles. We see like vertical angles. We're only going to look at angle AEB, although this process would fit for any of them. So the measure of angle AEB is going to equal the sum, 1/2 of the sum of the two arcs that are intersected by those chords. So what do I mean by that? I mean arc AB and arc CD. So 1/2 the measure of arc AB plus the measure of arc CD. Take a moment and try these two examples by yourself. Then unpause the video to find the answers. In the first example, we know that this is an inscribed angle, and that angle, the x degrees, is going to be 1/2 of the measure of the arc that it intercepts. Well, that's 116, so half of 116 degrees is 58. In this second example, we see that angle A, we'll give this a letter, angle ACB is a right angle. So if the measure of angle ACB equals 90 degrees, and we know that it's 1/2 of arc AB, so 1/2 of the measure of arc AB equals 90, that means that arc AB is going to have to be a 180 degrees, which means that AB is actually going to be a diameter of that circle. In this example, we're looking for a little bit more than in the last two. So take a moment, pause the video, and see what you can figure out. So we know that the measure of angle BEF is equal to 1/2 the measure of the arc that it intercepts. And in this case, the arc that it intercepts is BAF or FAB. Now, we know that measure of angle BEF is 96 degrees. So that means that twice 96, which is 192 degrees, is going to equal the measure of angle of arc FAB. But we already know that arc AF is equal to 99 degrees. So to find the measure of arc AB, just like we did in the first video, we can add the arcs together. This time we're going to subtract. So when we subtract, we find that the measure of arc AB is 93 degrees. So I'm going to fill that in on our circle. So now we can go about figuring things out in similar manners for angle ABE with arc EF, and then we can subtract from 360, because remember, the entire circle is 360 degrees, to find arc B. So here we've gone about finding the remaining arcs. Now we can proceed to find our remaining angles. So now we found the measure of angle AFE, which is the same thing as D degrees in our diagram, which is 80 degrees. And if you're thinking, hey, wait a second, that figure inside that circle is a quadrilateral, I know it has 360 degrees, you would be correct. So you could find the remaining angle using quadrilateral properties as well, but we could find it using our angles, and when we do so, we end up either way we find it with C being 84 degrees. Let's look at one more example. If we have these two chords, AC and BD, and we know that the measure of arc DC is 46 degrees and the measure of arc AB is, say, 90 degrees, we can find the measure of, let's give this a letter E, the measure of angle AEB is 1/2 of 46 plus 90. And when we simplify, we end up with the measure of angle AEB is equal to 68 degrees. In this example, if you notice it's slightly different, this time we are trying to find the measure of the arc that is intercepted. So we would proceed the same way. 75 degrees is equal to 1/2, or a similar way, 120 plus x. And now we have to get rid of that 1/2, so 150 equals 120 plus x. So x is equal to 30 degrees. After watching this video and taking some notes, you should complete Circles worksheet, numbers 1 through 7, and numbers 13 through 15 on the reverse side. There are additional problems on the worksheet that you can attempt if you feel like you need additional practice with this topic.